Previously, we have covered the node voltage analysis for a systematic approach for circuit analysis. Now we will cover the second approach, which is the mesh current analysis. Specifically, we will first define the mesh currents and then learn how to solve the mesh equations. After doing the mesh current analysis with current and voltage sources, we will extend it to the dependent sources. And at the end of this lecture, we will make a comparison of the node voltage and mesh current methods and learn in which conditions we should use one of these methods. Mesh current analysis can only be applied to planar circuits. A planar circuit is a circuit which can be drawn on a plane without crossovers. For instance, this circuit here is not a planar circuit because we have one crossover here. In mesh current analysis, we consider the analysis of circuits using Kirchhoff's voltage law around a closed path. A closed path or a loop is drawn by starting at a node and tracing a path such that we return to the original node without passing an intermediate node more than once. A mesh is a loop that does not contain any other loops within it. So, in other words, the meshes are the smallest loops. Let's see what type of meshes we have in this circuit. I see one mesh here. I start and go back to the same point without crossing any other node more than once. I have another mesh here. I have another mesh here. Another mesh here. And I have 4 meshes in this circuit. Let's make an important definition. Mesh current is the current which flows through the elements constituting a mesh. We use the clockwise direction for defining the meshes. One of the standard methods for analyzing an electrical circuit is to write and solve a simultaneous set of equations called the mesh equations. The unknown variables in the mesh equations are the mesh currents of the circuit. So in other words, if you find the mesh currents, then we can find all the currents and voltages of the circuit. Remember, in node voltage analysis, on the other hand, we were finding the node voltages. In order to write the mesh equations, we do 2 things. We express element voltages as a function of mesh currents. And secondly, we apply KVL to each of the meshes in the circuit. For instance, in this case, I have a mesh current I1 and mesh current I2, and the current passing through this element in this direction is I1 minus I2 because I1 is passing going down, I2 is passing going up, and the current going down is I1 minus I2. Here in the second case, I have this current 3 amperes going upward. So here I have I1 minus I2, which is equal to minus 3 amps. And over this element, I have the current I1 minus I2 passing. So therefore, by convention, the voltage over this element will be V is equal to R times I1 minus I2. Here I will write 3 mesh equations for the mesh currents I1, I2 and I3. Let's start with mesh 1. R1 times I1 plus R4 shares 2 mesh currents I1 and I2, so therefore it will be R4 times I1 minus I2, and this will be equal to Vs because we are entering to the negative terminal of the voltage source, and therefore I am writing it to the right side. Let's try to write mesh 2. R2 times I2 plus R5 times, this time I5 is being shared by 2 mesh currents I2 and I3, I2 minus I3, and I have R4 times I2 minus I1 is equal to 0. There is no constant here. And I have the mesh current for the third mesh. So R3 times I3 plus Vg plus R5 times I3 minus I2 will be equal to 0. So how can I solve this? I can solve this maybe writing these equations in that matrix equation. Here I have my matrix. Here I have my vector of unknowns, which will be I1, I2, and I3. On the right side, I will put the constants. What are my constants? Here I have Vs. For the second equation, I have 0. And for the third equation, I have Vg. So accordingly, I have Vs, 0, and minus Vg, because I am taking Vg to the right side. And let us try to populate the matrix together. Here, for the first equation, I have R1 plus R4 times I1. Then I have minus R4 times I2. And I don't have any terms related to I3. So therefore, I'm writing a 0. For the second one, I have minus R4. For R2, I have R2, R5, and R4. R2 plus R4 plus R5 related to I2. And for I3, I have a single term minus R5. So I have right now my second equation also written here. Now let us try to write the third equation. In the third equation, I don't see any terms related to I1. So therefore, I am putting here a 0. Related to I2, I have minus R5. And for I3, I have R3 and R5. R3 plus R5. So now I have written my equations in the matrix form. A times I is equal to V. And in order to solve this, I can, for instance, use MATLAB. A times I is equal to V. I will be equal to A inverse times V. In the mesh current analysis, we try to find the mesh currents by writing KVL equations. However, if we have an independent current source, in this circuit we have it here, then if this is only part of one mesh, and in this case it is only part of the mesh 2 through which the mesh current I2 is passing, then we can just simply state that the value of I2 is equal to, in this specific case, minus IS, and therefore I don't have to write the KVL equations for this specific loop. So we only need to solve the circuit for the other meshes, in this case the mesh 1. And I have another case in which the current source here is a combination of two mesh currents, I1 and I2. Obviously, in this case, I can write one more equation in which I can write IS is equal to I2 minus I1, because I2 is in the same direction with the IS and I1 is in the opposite direction of IS. However, I have this additional equation, but I have another additional unknown. I don't know the voltage over this current source. So therefore, I will define another voltage, which is VAB. And then I will write my KVL equations for two meshes. For mesh 1, I will write R1 times I1 plus VAB will be equal to, since I enter from the minus side, I write this to the right side, is equal to Vs. And for the second mesh, let me write it here, mesh 2, I will write R2 times I2 plus R3 times I2. These are just simply in series, is equal to, since I enter from the minus side to this VAB, is equal to VAB. So I have the unknown I2, I have the unknown I1, I have the additional unknown VAB, but I also have 1, 2, and 3 equations. So 3 equations, 3 unknowns, I will be able to solve this circuit. Alright, let's solve this example. The easiest equation I can write here is I1 is equal to 4 amperes, because this 4 amperes current source is not being shared by any other meshes but mesh 1, and therefore I1 is equal to 4 amperes. Now let us write another simple equation. I2 minus I3 is equal to 5 amperes. So I just basically know that I3 is going downward in the same direction of this current source. I3 is going upward. So, and we know that this current source is 5 amperes. So I2 minus I3 is 5 amperes. But this comes with its own slight complication. I need to define here the voltage of this current source as VAB because I don't know what that is. Let us write the Kirchhoff's voltage law for the mesh 2 and mesh 3. So R1 has the value of 1, so I2 minus I1 plus VAB is equal to 10. So I will write this is the first equation, this is the second equation, and let me write the third equation for this loop. So I3 minus I1 times R2, which is equal to 1, plus R3, which is 2, times I3 is equal to, I am entering from the negative sign of VAB, therefore I write it to the right side, is equal to VAB. So I write this as my third equation. So I can simplify this third equation indeed a little bit. So I can write 3 times I3 minus I1 is equal to VAB. Let's change color such that I don't get confused. I can write this VAB into this equation. I2 minus I1 plus 3I3 minus I1 is equal to 10. Let's simplify this little bit. I know I1 is equal to 4. This is also 4. I2 plus 3I3 is equal to 18. I know I2 minus I3 is equal to 5. If I subtract this equation from that equation, I end up with 4I3 is equal to 13. And from here, I find I3 is equal to 13 over 4 amperes. This is good. Now I need to find I2. Let's write the equation number 1, this equation. I2 is equal to 5 plus 13 over 4. So, and if I am not wrong, this will be equal to 5 times 33 over 4 amperes. So I know I1, I know I2, and I know I3. I solved for all three mesh currents and I can conclude my circuit analysis. Similar to the supernode concept in node voltage analysis, we also have the supermesh concept. A supermesh is one larger mesh created from two meshes that have an independent or dependent current source in common. Here we have this current source of 5 amperes, which is shared by the mesh 1 and mesh 2, and therefore I can create the supermesh, which is a combination of those two meshes. In this case, we will do our mesh current analysis by writing the Kirchhoff's voltage law only for the supermesh and writing an additional equation which relates I1 and I2 using the independent current source. Alright, let's solve this one using mesh currents method. The simplest one I can write is I1 minus I2 is equal to 5 because I1 is going this way, I2 is going this way, and 5 amperes have the same direction with the I1. Secondly, I can write the mesh equation. This is the mesh. Let's start with this 1 ohm resistor. I1 minus I3 times 1 ohms, but I will not write that, plus 3 times I2 minus I3 plus 2 times I2 is equal to 10. So this is my second equation. Let's write this equation in the simpler form.
by collecting the terms I1 plus 5 I2 minus, if I am not wrong, 4 times I3 is equal to 10. So let's number this one as 1. Let's write this one as 2. And we need to write the third one for this loop with I3. 2 times I3 plus 3 times I3 minus I2 plus 1 times I3 minus I1 is equal to 0. Let's simplify this as we did for the second equation. Minus I1 minus 3 times I2 plus 6 times I3 is equal to 0. And I have this third equation here. So I have 3 unknowns, 3 equations. I can do a very messy algebraic manipulations to solve them, or I can write them in matrix form and solve using MATLAB. I will choose the less messy form, I1, I2, I3. For the right side, from the first equation, I have 5. From the second equation, I have 10. From the third equation, I have 0. What will I have inside the matrices? From the first equation, I have 1, minus 1, and 0, because there is no term related to I3. From the second equation, I have 1, 5, and minus 4. And from the third equation, I have minus 1, 3, and 6. So if I go to MATLAB and solve this, what will I get? Let's wait a bit. I get I1 is equal to 7.5 amperes. I2 is equal to 2.5 amperes. And I3 is equal to 2.5 amperes. So I found the 3 mesh currents and I am done with the solution of this circuit. Now in this question, I will determine the mesh currents using the Supermesh method, because both of these meshes are sharing this 1.5 ampere current source. So I1 minus I2 will be equal to 1.5 amperes, because I1 is in the same direction with the current source and I2 is in the opposite direction, therefore it is minus. Now let us define our mesh as the whole circuit. And accordingly, let us try to write the mesh equation. 9 times I1 plus 9 times I2 is equal to 12. From the first equation, I can write I1 is equal to I2 plus 1.5. And if I take this expression and then plug into this expression, I end up with 13.5 plus 18 times I2 will be equal to 12. From here, I can calculate I2 as minus 1.5 over 18, which is equal to minus 1 over 12 amperes. And once I have I2, I can calculate I1 as 3 over 2 plus I2, which is equal to 3 over 2 plus minus 1 over 12. So which will be equal to 18 over 12 minus 1 over 12, and accordingly it will be 17 over 12 amperes. So I have right now both I1 and I2. These are all the mesh currents in the circuit. Therefore, I can conclude my circuit analysis. When a circuit contains a dependent source, in this case we have a current-controlled current source, the controlling current and voltage of the dependent source must be expressed as a function of the mesh currents. When I try to solve this question, how can I start? I can start by defining my mesh currents, I1 and I2. I need to find the voltage of the voltmeter, which is basically plus minus Vm here. And I can write my first equation simply as IA is equal to I1 minus I2, this current, I1 minus I2. And what else I can write? Here is a nice relationship. I2 is equal to 5 times IA, because this mesh current I2 is passing in the opposite direction through this current source, and I can write this equation as well. Let us try to write another one. I can write a simple Kirchhoff's current law for the first mesh. 32 times I1 is equal to 24 volts. Accordingly, here I have I1 is equal to 3/4 amperes. So I found this. If I were to go and write this to the first equation, IA is equal to 3/4 minus I2, and I can plug this into that. So I have minus I2/5 is equal to 3/4 minus I2. From here I get 0.8 I2. I will write it as 4/5. It will be easier, I guess. 4/5 I2 is equal to 3/4, and from here I will calculate I2 as, if I will not make a mistake, 15/16 amperes. After I find this, I need to find what is being measured by the voltmeter. I can write, in order to find that, the Kirchhoff's voltage law for the second loop. 32 times I2 plus Vm will be equal to 0. So this will be 32 times 15/16 plus Vm will be equal to 0. This cancels that. Here I have 2. Accordingly, I have Vm is equal to minus 30 volts, if I have not done some silly mistakes.
So far, we have learned two methods for systematic analysis of circuits, node voltage and mesh current methods. In some cases, one method can be preferable over another. In general, as a rule of thumb, if the circuit has both voltage and current sources, we should count the meshes and nodes. If nodes are less, we should use the node voltage method. If meshes are less, we should use the mesh current method. However, we should not forget that the mesh current method is only applicable to planar networks.
We need to find the resistance R. So we need to first do the circuit analysis. What would make sense, to do node voltage analysis or mesh current analysis? It would be much easier to do the mesh current analysis because we are given all the mesh currents, so it is trivial. Let's define our mesh currents. I1, I2, and I3. Here, simply, I1 will be equal to 1 amperes, I2 will be equal to 3 amperes, and I3 will be equal to 0.5 amperes because it is being measured by the ammeter. But now I need to find the value of R. How can I find this? I can write KVL for mesh 3. So let's try to write this. 2 times I3 minus I1 plus 12 times I3 plus R times I3 minus I2 will be equal to 0. Let's plug in the values of the currents, mesh currents. 2 times I3 is 0.5. Okay, 2 times minus 0.5 plus 12 times 0.5, it will be 6, plus R times I3 is 0.5, I2 is minus 2.5 is equal to 0. From here I get 1 minus 1, and 5 is equal to 2.5 R. Accordingly, R is equal to 2 ohms. So I solved my question. As you can see, by using the mesh current analysis, the more preferable circuit analysis option, it was very easy to solve this question. So we need to find the resistance are, when I see this circuit, I see some voltage values and I can utilize those. So I don't see a specific reason why to use the mesh currents to solve this question. I will define my reference node as here. Here I will put 16 volts. And here between the reference node and then this node, 16 volts is measured. So I have 16 volts here as well. So accordingly, I will know that the current passing through here is equal to 0 because we just don't have any potential difference. So if we don't have any potential difference and the current is 0, I will not have any currents passing this way. All of these 2 amperes will pass through this resistance. So if it is all passing through this resistance, R will be equal to 16 volt divided by 2 amperes, which is equal to 8 ohms. Very easy.